When you are graphing a function, and in this case I'm asking for specific points, you can plug this into your calculator, which is just fine, but I need you to go to the table to make sure you're graphing 3 specific points for each of these functions. So for this first one, negative 3x squared plus 4, just plug that in your calculator, negative 3x squared plus 4 and your y equals. And then on your TI, you would go to second and then graph, and that would take you to your table. And it would show you a couple of these points. So anything that fits on your graph. So negative 2, negative 8, and 3 is the minimum, but you can always do more than that, which is what I'm going to do. So negative 2, negative 8, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 1, 0, 4. And then I think it's reflected and comes back down just like this. Yep, it sure does, and then you just connect. And again, you can look at your graphing calculator and it will show you what the shape of this graph looks like, but I do need specific points to be graphed. I want to see your dots on your graph, just like that. And then we have to decide, after we graph, then determine if each is a one-to-one function. So remembering one-to-one function, well, first of all, we have to decide if it's a function by using a vertical line test. So we take a vertical line, we run it across our graph, and if it ever touches more than 1 point on the graph at a time, then it fails. But we're okay, that is a function, it passes the vertical line test, but if we want it to be a specific one-to-one function, it also has to have an inverse, meaning it has to pass the horizontal line test, which this one does not, because this horizontal line passes through my graph twice. So that means the inverse function does not exist, and this is not a one-to-one function. So one-to-one has to pass the vertical and horizontal line test.